So they build this in 2500 BC, and then it takes us until 1800 AD in order to build something taller.
Break it down from there. So if you go, well, it's 25 years, 2.5 million blocks of stone, it basically means for 25 years, you have to be putting one block of stone in place, finished, shipped, carved, quarried, put in place every 5 minutes, every day for 25 years. There's these massive floor tiles that have been put into the ground. Some of these things weigh up to like 200 tons. And they're fit together like a geometric puzzle and done so precisely you can't stick a razor blade in between the gaps.
I didn't know that.
Take the height of the Great Pyramid, you multiply it by 43,200, you get the polar radius of the Earth. So
what does that mean, polar radius?
So from the center of the Earth to the North Pole, polar radius. If you take the perimeter length of the Great Pyramid, you measure around the perimeter of it, and you multiply that by 43,200, you get the equatorial circumference of the Earth. So
I want to bring people in. Obviously, people are familiar with the pyramids. They see these great structures. They go, oh, this is amazing. They've heard people say, oh, the aliens built them, etc. Can you just break down why the pyramids are so amazing outside of just the visual stimulus that we've all seen in postcards?
Well, yeah, I mean, the reality of them is probably stranger and more interesting than anything people can think up in terms of fiction. It's just they're for the longest time have been not only like the tallest man-made structure, but they've been some of the most precisely man-made structures we've ever accomplished. Like we didn't, wasn't until like the 1700s that we even developed enough precision to be able to define just how accurately those things were aligned to things like true north. We're still discovering crazy coincidences about them in terms of, they're encoding these fundamentals of nature. The Great Pyramids, I can talk about it a bit. It's a scale model of the Northern Hemisphere. It's just like,
what do you mean by that?
Well, let's
break down some of the precision.
Sure. So the Great Pyramid. Mostly that's the one that's been studied. We actually haven't done a whole lot of studying on the other pyramids. It's something that's severely lacking. In fact, we've not even cleared off the bases of some of the other pyramids up at Giza. It's crazy. We still to this day haven't done that. But that pyramid itself, the Great Pyramid, the one that we all know and look at, the biggest one, it's aligned to true north within just a fraction of a degree off. I mean, we just don't build with that type of precision even today. In fact, the only building we made that was that precise was like an observatory in France. That was the first one we ever made that even came close to that degree of precision. They made that in the 1800s. That's just one aspect of it, though. It's insane. Apart from it being just the tallest building for forever until the Eiffel Tower was built.
So the traditional historical narrative is that these were built, 4,500 years ago?
Something like that, somewhere around the 2,500 BC.
So they build this in 2,500 BC, and then it takes us until 1800 AD in order to build something taller.
Yeah, just taller, not even as precise.
Yeah, nowhere near as
1,000 years later, 4,500 years later, whatever it is.
So you understand why people start to question the historical narrative.
Well, it falls apart under any rudimentary examination, just the logistics of trying to build that thing alone. So you have to, there's very little evidence that actually ties it to the guy they say who built it. A guy named Khufu, who's like a pharaoh of the 4th dynasty, Old Kingdom. And they have to try and tie it to, because the whole story is like it's a tomb for him. So, when he came to power, he probably said, we're going to build this thing as my tomb. So they had to get it done inside his reign.
Right.
So that sort of pins it to 20 to 25 years.
Okay.
So you can break it down from there. Okay. You say, it weighs like 5 million tons. And no kidding. And it's made up of around somewhere between 2 and 2.5 million blocks of stone weighing, any of it like 2-3 tons. Some of the big granite blocks on the inside weigh like 70, 80 tons. It's insane.
And these blocks are coming from quarries that are...
Some of them, the granite came from quarries that are like 1,000 kilometers away to the south. They had to be shipped up. A lot of the limestone, so it's made up of granite in the inside. The outside is 2 types of limestone. The core masonry is this limestone. A lot of it did come from Giza, not all of it. There's actually nowhere near enough quarrying to make up for all of it. The Cairo area, and then the outside casing stone is something called Tura limestone. It's a very fine white version of limestone that came from a fair distance away. But you can break it down from there. So if you go, it's 25 years, 2.5 million blocks of stone, it basically means for 25 years, you have to be putting one block of stone in place, finished, shipped, carved, quarried, put in place every 5 minutes, every day for 25 years.
24/7, nonstop.
24/7, nonstop. And now that
were union hours.
No union hours. Yeah.
Overtime.
Yeah, no breaks, no whatever it is. I mean, It's crazy, and that is only the pyramid. And you got to remember also, pyramids are part of a complex. There's
2 other pyramids there, and
no,
there's like 3 little.
there's a bunch, yeah, there's like 9 or 10 there, originally. But there's just that one pyramid. It's not just when you build these pyramids that they're part of a complex, not the other pyramids, but they have a causeway. They have these. They call everything's a temple or ceremonial, but there's temples. There's years of work just in preparing the ground, the whole foundation of what's around the pyramid. I love going to Egypt and showing people. Everyone stands there and they look up at the pyramids. I'm like, look down at your feet. Look at what you're standing on. There's these massive floor tiles that have been put into the ground. Some of these things weigh up to like 200 tons. And they're fit together like a geometric puzzle and done so precisely you can't stick a razor blade in between the gaps.
I didn't know that.
Oh, it matters. It's
on that at all. So you're saying that they dug down and then created a flat surface,
a foundation,
and then tiled the foundation.
Yeah, with these, but some of these, I mean, you're talking tiles this thick, some of them even bigger. In fact, the middle pyramid is even more impressive in that regard. Because it's built into a side of a hill, like it's literally a sloping hill. So they dug down on this side and they raised it up on this side. They made this flat platform for it, and it's just astonishing engineering. So you got to factor in, and of course these types of projects you don't just make it up as you go along, right? So how long do you take to design it, plan it, put the plan that's years. Doing the foundation work, that's probably years.
You have to make sure there's enough stone to even achieve it.
Just logistics is this massive problem. I actually would love to do the exercise of working backwards, because we've done some experiments on things like, okay, using really primitive methods, which is what, the mainstream guys say they used. It takes this long to cut stone. We've done a few little experiments here and there, but you can use that and work backwards, try to estimate how many cuts of stone do we need? How long would that have taken?
Yeah.
How long is it going to take to ship it?
Oh, that's right. You can see based on, what is it, axe and chisel or whatever it is?
Yeah, chisels. This is the
hammer and chisel.
The stupidest thing about it all is these wonders of ancient Egypt, the pyramids, these giant granite single-piece statues and columns, and they tell you that it was all made with round balls of stone and flint chisels, just like repeatedly bashing on them.
So let's
like grinding on them with sand.
But let's assume it was. You could calculate. No. But even if we were to calculate how long it would take to take that round stone and the chisel and chip away and create these perfectly, they're not even symmetrical, but like these perfectly shaped, blocks.
I wouldn't even be able to get them perfectly symmetrical, but even as close as you could.
How long it would take.
Yeah.
And have you tried to do that math?
No, but it's on my list of things to do. In particular, I'm interested in like the granite as well, because
the granite's so hard to grind.
Granite's so hard. There's a few things involved in the granite. It's they say, well, they grinded on it with sand, or like they get a copper bar, and we've done these experiments. It's much harder. Like that's the other thing that people try to compare, like the work of the Romans and a lot of times the Greeks. They all worked in marble. Like this is a very, very soft stone relative to granite. Like frankly, granite's a stupid material to try and do this stuff. It's harder than steel. It's like a 6.57 on the Mohs scale. Diamonds at a 10, your fingernails at a 2, coppers at 3, bronzes at 4, scales like a 5 and a 6.
What is marble, out of curiosity?
Marble's I think it's like a 3-ish.
So it's theoretically twice as hard.
Yeah, and just super hard.
You had mentioned molecular manipulation.
Yeah, so that's the speculation realm. Architects, people look at it and they just see it immediately and go, this is nonsense.
Yeah.
This isn't the work of a primitive civilization or a Bronze Age civilization with simple tools. And then, you come back to the pyramid, and when you start to realize, like, there's so much more involved in this. There's evidence of this, of the people that build it having, cosmic knowledge, having knowledge of the planet, the dimensionality of the Earth to a crazy degree. Like, so if you take here's an easy statistic. If you take the height of the Great Pyramid, you multiply it by 43,200, you get the polar radius of the Earth. So
what does that mean, polar radius?
So from the center of the Earth to the North Pole, polar radius. If you take the perimeter length of the Great Pyramid, you measure around the perimeter of it, and you multiply that by 43,200, you get the equatorial circumference of the Earth. So the length of the
equator, 43,000.
This gets into Randall Carlson territory. It's a 43272. 7. It all relates back to I guess the cosmic sort of cycles and all of these are precessional numerology. When you talk about precession of the equinoxes, are you familiar with this term? So it's the great year. Right now we're in the age of Pisces. It's that 26,000 year cycle that's defined by where the sun rises on the solstice, And it's like, under what constellation does it rise? So right now we're in the age of Pisces. They even have knowledge of the pyramid. It encodes the specific shape of the Earth. By that, I mean the Earth being this oblate spheroid, right? We're a little bit fatter around the edge than we are around north-south, right? Because we spin.
Yeah.
So we're not a perfect sphere. That ratio, you'd call it the ratio of latitude to longitude. So if you take that grid of latitude and longitude, you spread it out on the planet, you go down to 1/4 of 1 degree, and you measure it so it's a little bit further sort of east-west than it is north-south. That ratio of latitude to longitude is expressed in the pyramid.
Oh.
Because it sits on something, I talked about the foundation. It sits on the foundation called the socle. So it's like they call it, it's a cubit height. It's about this high, sticks out about this far. So it gives you two ways to measure the perimeter length, right? You can measure the base of the pyramid, or you can measure the base of the socle being slightly larger. And when you ratio or you compare those two numbers, it's latitude and longitude. And bear in mind that we couldn't figure out how to measure longitude accurately in our own civilization until the turn of the 19th century. I think that's when it was. James Cook's the second voyage of discovery. We could not measure longitude to save ourselves until we developed chronometers and watches accurate enough to do so.
And you're saying, according to the traditional archaeologists 4,500 years ago, and you believe probably much longer, they knew.
Yeah.
So if we're accepting,
They knew the shape of the Earth.
Yeah.
if we're accepting traditional archaeology, there's just all these crazy coincidences.
Yeah.
And none of that, they had no idea that if you multiply it's the longitude, and latitude.
It's at that time they just were not aware. They were not privy to this. There's no proof to show that they were.
They say it's a coincidence. All of these things, you keep coming up with them because there's other, there's some people make an argument that the speed of light is encoded in the damn thing. There's all these crazy golden ratios and metrics when you get into like the King's Chamber and the geometry of that. It relates back to the meter. There's so many interesting studies about it, but it's generally all described and hand-waved away as well. It's just coincidence. And it's like, you can find this stuff and you can analyze anything.
You're approaching this, and like a lot of people in your position are going, these are a lot of coincidences. And it might be easier to look at these people who built the pyramids as a different group of people than the dynastic Egyptians that live, 4,500 years ago.
Exactly what I think. I think what we're looking at, and it goes so much further than the pyramids to me. We're looking at the remnants of a lost civilization, and that left stuff. They might have left cultural knowledge. They might have left architecture and objects that were inherited by essentially a Mesolithic people that developed into a Bronze Age culture that we call the dynastic Egyptians. I think we have a good understanding of the dynastic Egyptian civilization. The tools that we found, the way they lived their life, that's the job of the Egyptologist. And I think we're right about those guys. I just don't think you can say they made everything. And in fact, they themselves don't say that. Like, their own history goes back 40-something thousand years. Like,
so when do you think they're made?